Hey guys, welcome to today's video where we're going to be repairing this JL Audio 500/1. It's one of the Slash series amplifiers. They're one of the best-selling amplifiers ever made. Today's video is sponsored by Amarillo Cluster Repair. He sent this to us from Texas, so that way we could take a look at it on the channel. Basically donated an amplifier for repair. So yeah, we got this guy sent to us for free. He got this amplifier from his friend that owns Texas Auto Needs. They're like a tent shop over there in Amarillo, Texas. I'll try to show as much of the repair process as possible. Please bear in mind I'm rusty on amplifiers. It's been since 2019 since I've even looked at the inside of one. So maybe a little rusty for it, but it's definitely something I've been wanting to do. I want to do some amplifier repairs on the channel. By the way, if you want to see more content like this, I just need amplifiers to work on. Preferably stuff that you don't expect to get back. But here in our local area, we only have 1 or 2 audio shops, and I couldn't get them to return messages about broken amplifiers. But yeah, I'm not trying to do amplifier repair as a service where I'm like expected to get these things back to people, just because they're fun to do as a hobby. I don't necessarily like doing them for customers, mostly because of a lot of times what's breaking them is the setup. Like people mount them to their subwoofer, or they, have way too insufficient of a ground, stuff like that, where it's just like really bad installs, or, turning the gain all the way up and clipping it to death. Yeah, it's just like lots and lots of failures are just related to like poor installs. Obviously they're not all poor installs. Amplifiers do just fail over time, especially from vibration. You get a lot of vibration, cracked solder joints, stuff like that. Yeah, let's tear into this amplifier, see if we can get it fixed, and hopefully you guys like this. So here is the amplifier. I'm not going to try to turn it on. If you probe just the input here, you'll find that it's a dead short across it. So no point in trying to apply power to this. Let's go ahead. I've taken the back cover off. All's what there is to do that, or there's 3 screws, 1, 2, 3, go right there. So this is the back cover. It just slides in the channel down there, and you have the 3 screws. Big secret to amplifier repairs: you're never going to fix them in one day. You're going to have to order some parts, unless you do this all the time. And if you do this all the time, what are you doing here watching? Keep your hardware for the amplifier in a baggie. Just put it inside the amplifier, set the lid on top, so that way you don't lose parts, especially if you got a bunch of them. I used to do amplifiers pretty regularly, so that was my trick for not losing anything. The reason why we have a short across the input, this whole switch mode power supply, which is kind of this half of the board, is completely dead. There's pretty much no protection in between the amplifier stage. So this is the Class D amplifier over here. This is our switch mode power supply. There's pretty much no protection in between the two of these. So if one of these FETs shorts out, then it's going to take out the rest of these, which is the case here. This FET is shorted, and all of the output section's dead, other than the diodes probably fine. So let's go ahead and take these off. There's a little bit of a trick here, because we got to get this heatsink all the way off. To get these little clamps that hold the FET to the heatsink, I take one of these kind of tools here. It's got the little bend on it, come right underneath the thing, and just pull up on it. So we're going up that hole and prying kind of upwards on there, using the bottom of the spring here, because it's kind of a spring, and then you just pop them right off. Okay, so let's finish taking this heatsink off and get to it. Okay, another secret to amplifiers is just be ready to have your hands covered in thermal paste. It's gonna happen. This video, we're not really gonna get into the theory of Class D amplifiers. It's just kind of neat how the topology works. You basically take 12 volts and boost it really high voltage, switch it a bunch, and then filter it back into audio at that point. So you notice I tried to use the heat gun to remove those resistors. When I got to R606, I noticed that this pad was a little bit loose, so I decided I want to go a little bit more delicate of approach, so I used the 2 soldering irons instead. We do have one lifted pad here. I don't think that was from the rework. I think it lifted from the heat. And if you're wondering why I left this this FET on, it's actually the diode. So that's the rectifying diode. This is for your thermal protection. So we got also a little bit of exposed FR4 under here from the heat. It burned away the solder mask a little bit, but that's no big deal. So not a lot of damage to the board itself. And yep, we no longer have a short. We are charging the cap, though there's quite a bit of capacitance. So it's slowly going up. But yeah, we're at like 2K, so definitely no longer a short. So we can start getting the new gate resistors on here, replace all of our gate resistors, and then put the FETs on. I think all of my vias, my through holes are clear. It looks like I got a little bit left on these two. Okay, so the gate drive for all of these FETs are actually driven by another FET here, so let's make sure none of them are blown and make sure we have a good connection on all of our gate resistors we just replaced. So we'll go straight to the gate there. I have it wired up with the I have 12 volts ground and remote, and I have the remote wired to my 12 volts. I'm actually just putting in 10 volts. And so it takes about 5 seconds to start producing gate drive. Okay, and now we have started producing gate drive here. Okay, so we have all of our gate drives on the switch mode power supply. Let's see if we have any Class D. It's only going to come up for a brief moment every time I turn it on, so... All right, so watching me solder from the top down may have been kind of weird, but I find that kind of an easier technique with the MOSFETs to keep them from getting out of whack, because you kind of need them nice and straight, so that way they don't take up more space than they were originally, because you only have so much non-conductive material in there for the for that, because you don't want these shorted to the back of your heatsink. It's now been about a week here. You can you might be able to notice that there's a little bit of rework here. I was having a problem with this amplifier where I actually was not getting proper switching for the Class D side of the amplifier, so the output section. So I ended up having to kind of give in and ask on DIY Audio. It's a forum where they kind of talk about amplifier repair and building your own amplifiers and that kind of stuff. I ended up kind of caving in and asking on there if anyone else has seen this problem, because basically what was happening here is I couldn't change the duty cycle of the switching even with audio input, and it was only switching for about 100 milliseconds, and then they would just stop altogether. It turned out to be this op amp right here. It was shorted rail high on pin 3. This op amp and this comparator here make the Class D switching. It kind of sets the duty cycle. Kind of the way it works here is you have your sawtooth coming out of this 555 timer, going into the comparator with the audio on the other side, and that kind of makes your pulse width, if I was understanding correctly what I was seeing on there. But again, without a schematic, I am kind of making a little bit of a guess here on how this works. So I replaced this op amp, and that fixed the problem. However, in the process of diagnosing it, taking on and off this board a bunch, I wore out one of the pins on this connector here, and it wouldn't even come on at all after that. So I ended up replacing this connector as well. Basically, what's been replaced here is this op amp, this connector, and I actually replaced the gate driver, which is the little IC right here. You probably can't see, it's hidden underneath that. Had to take off this cap to change out that gate driver. The gate driver, I just had one, so I figured I might try that before. This was kind of like my last ditch effort before I went searching on the forums of how this amplifier works to get it. I kind of thought that the Class D switching was going to be generated like right here, but that is not the case. So yeah, with the help of the forums, I got this back up and running. I can't say I got it up and running by myself, because they definitely, without Perry's help, I would not have gotten this up and running. But yeah, let's go ahead and finish getting this back together. Well, I guess we're not putting it all the way back together. I just need to put that preamp board on so that way I can show it working. So I have some output here, some power input here, and we'll put a some input from my signal generator there. We have our 14 volts and then a jumper to the remote sense, so that way we can turn on and off remote sense. The input here is going up to my signal generator, and we'll be feeding it a 200 hertz sine wave. We're going to start at 200 millivolts, and then we'll go up from there. So 200 millivolts would be kind of similar to an input from like the speaker output of a cell phone. You can get up to like 500 millivolts most. But yeah, we're gonna turn this on and check for our offset. So we're gonna make sure we don't have some DC component setting us higher, and then just check and make sure that we have a good looking sine wave coming out. Obviously this is at no load because we are not in a heat sink. So when we first turn it on, we're pulling about 500 milliamps, and then we start building rail voltage. Once we've built our rail voltage, now it pulls about 1.5 or 1.25 amps. And we see that we don't have a DC component there, so we don't need to adjust the offset. If we were having a problem with that, there's a potentiometer right there where you can adjust your offset. Okay, so now let's start feeding it a sine wave. And there we go. We get very little squiggles there. So let's start going up in amplitude. So obviously the amplifier is in fact working. So we can start putting it back down into a case. Okay, at this point you need to kind of slow down and make sure that your isolation piece here is lined up nicely with your MOSFET. So let's go ahead and feed it that signal. And we're doing 100 hertz. And let's go ahead and give it a little bit. Okay, and let's disable the remote, make sure nothing crazy happens. And then we will turn off power. So I think we can call this repaired. Obviously, I didn't load it down a lot. The 4 ohms and we were pretty low on amplitude. So I wasn't paying too close attention to what our amplitude was there. It looked like it may have been upwards of 10 volts. So we were at 10 volts with 4 ohm load here. So that'd have been like 25 watts. So we really weren't loading this down very much compared to what it could be loaded down to. However, the little lab power supply I'm using right now just wouldn't be able to, one of my larger 1.5 kilowatt power supplies to do that. But I also don't have a load that I can actually put that much power into. I'm sure I'd blow out these speakers before I got this all the way up. So yeah, I think that's about it for testing on this that I'm going to be able to do with what I have around. Well, hopefully you guys enjoyed this video. I know I kind of skipped around a little bit in the editing this time. It was because I wanted to keep this video a little bit shorter. I was looking at closer to a 40-minute long video. So I trimmed it down as much as I could. And again, a big thank you to our sponsor, Amarillo Cluster Repair. And maybe in the near future, we'll do an amplifier giveaway. I would like to get these back out to people that could use them. This one, I'm not sure if I'm going to do that with. I do have another amplifier for repair. Haven't even opened it up yet, so I'll break into that one and see what's going on there as well. And for those wondering what's coming up, we have the J1850 variable pulse width module that's coming back. I'm waiting on the boards to show up that I ordered. I ordered some new blank boards, did a little redesign there. So once those get in, hopefully this week, I'll be able to start doing a video on that. And I still need to do the Carvana follow-up video. I just have been busy with this amplifier repair and other things. So yeah, definitely stay tuned for more videos, and I'll see you guys in the next one.